This is EGR 101, the fourth lecture in our series of revolutionary engineering and the engineers that created them. This is Admiral Rickover and the development of nuclear power. Hi, hope that everybody is doing well. What we have pictured here is a Virginia-class fast attack nuclear submarine. Now, the reason that I'm showing this is that this article relates to the development of nuclear power, first for submarines like this and then later for commercial power plants. This nuclear submarine was considered at the time of its development the most complex machine that humanity had ever devised, and they really are quite something. The key to this is called the nuclear power plant with the reactor and steam generators. That is the heart of this, and it's because of our ability to understand how to engineer this and put them into a submarine that allowed us to use these first for military applications, later for civilian use as power plants. So this man here, Admiral Rickover, is considered by many to be the father of nuclear power. Not just military nuclear power, but also civilian nuclear power. So here's how he did it. In 1948, he was directed by President Truman to find a use of atomic power other than just building weapons, which is all that we knew how to do in 1948. So he went to Oak Ridge National Laboratory with a small team of people. And the people he brought were several naval officers that were knowledgeable and trusted by him, as well as several civilian engineers from some major companies, General Electric and Westinghouse. They worked on a chalkboard, and they learned from the scientists at Oak Ridge National Laboratory how nuclear fission works, and they worked out how they could take those principles and package it into something that made nuclear power. Now, they didn't have a lot to go on at that point, so remember, with revolutionary engineering, you don't have something that already exists that's similar that you can then just revise or scale up. You have to find some other way of doing this. He looked at two different sources here. The first one, the obvious one, were the reactors that were out at the Hanford facility in Washington. They were big piles of graphite, and they were being used to turn naturally occurring uranium into weapons-grade materials such as plutonium. So he understood the basic principles of that, but he also then looked at chemical engineering because he saw in chemical engineering something analogous to what we were doing here. Chemical processes in a reactor, those processes oftentimes are exothermic, creating steam, or creating heat, I should say, and then that heat can be turned into steam to create electricity or to drive a ship. So he figured out the basic principles behind this, and then they worked on their very first designs, first small-scale designs at the two national laboratories, the Bettis Atomic Power Laboratory in Pittsburgh, Pennsylvania, and the Knowles Atomic Power Laboratory up in Schenectady, New York. Bettis was run by Westinghouse, Knowles was run by General Electric. So from those small-scale tests, then they built their very first prototype. Notice he's walking his way up to a final design. The prototype was built out in Idaho at the National Engineering Laboratory, and it was a piece of a submarine. And the few times that I've walked into that facility, it's quite shocking to go from flat desert with mountains around you into this building, this big warehouse, and there's a piece of a submarine sitting in a tank. But that allowed them then to perfect their engineering, and then from that point they were able to work with Electric Boat Division in Groton, Connecticut to package this into a real submarine. And this is the amazing thing. They went from the chalkboard to the world's most complex machine ever devised by people in 7 years. It was just totally amazing, and they did it by how we're describing. They worked on it in pieces. Now, there's a deeper story about Admiral Rickover, and it relates to the lectures that we had last week. I have never known a man in my life who has gone through more adversity than this man. He started out being born in a part of Poland that was controlled by Russia. In 1900, he was a subject of the Tsar of Russia. Now, he was a Jew, and they faced huge discrimination, persecution in those days. It's really tragic, some of the things that they went through. His family realized that they needed to move, and they moved right around, I'd say just before World War I. They moved, and they finally settled in a South Side neighborhood called Lawndale in Chicago. So Admiral Rickover was a South Sider. I'm a South Sider. Yeah, go Chicago. He did rather well there. He studied, he worked hard, he got good grades in high school, and he was able to get an appointment to the U.S. Naval Academy at Annapolis, Maryland. Now, you must understand what that meant. At that time, if we were to go to Annapolis, we would see most of the students there had some commonality to them. Many of them had relatives that had been former naval officers as well. There was very much a tradition there of sons of fathers and grandfathers who had been naval officers going to the academy. They were mostly people from the East Coast. Definitely in terms of religion, he was a minority. He was one of just a handful of Jewish students there. And also his size and stature set him apart. Most people that went there you could think of as varsity athletes. That wasn't Admiral Rickover. So he faced 4 years of pure hell. Somehow he got through that, did well at the academy, and well enough that he was able to get through that and have a choice of pretty good duty, which in this case he chose submarines. Now, I don't know why he chose submarines, but something about the technology intrigued him. He did well in his first duty stations there. He always found a way to do well despite adversity, and he talked the Navy into sending him to Columbia University to a master's program in electrical engineering. That opened his eyes to the power of engineering. I mean, it really changed his life. And from then on forward, he said, I'm an engineer. That's what I am. And when he went back into active service, he started working to improve the electrical systems in our submarines. He made them much more efficient, improved range, power consumption, multiple things that made our submarines actually quite good. And he developed a reputation through his engineering, so much so that when World War II came out, he had a very key role in developing the systems that helped us be successful in the Second World War. Subsequent to that, he was then ordered to find a peaceful use for nuclear power, which he did. Now, fast forward from all this from the 1940s and early 50s to 1974, and here I am at Purdue University in Naval ROTC. Now, my degree objective was aerospace, aeronautical, astronautical engineering, and I wanted to do that. I wanted to fly planes. At least I wanted to design planes. Well, I did okay my first semester. Well, my first semester was really not pretty, but my second semester, I came to the realization that I needed to focus on the learning, not the grade, and then I needed to do the homework as soon as it was assigned so that I could keep up with things, and it was showing in an improvement to my grade point average. By sophomore year, that first semester, I got nearly straight A's. I mean, it was quite an improvement. So the good news is I was getting pretty good grades and I was learning the material. The bad news is I got on his radar. So at the end of my first semester sophomore year, they sent me a letter from his organization directing me to them. I now was a nuclear propulsion officer candidate. So there went my dreams of flying airplanes. And I was directed to maximize my grade point average and report to him my senior year for an interview. Well, I dutifully did that, and February of my senior year, I reported to Washington, D.C. for an interview. And I went through interviews with his organization, some of the most grueling interviews of my life. And at the end of it, my head was really hurting. I was tired. I was hungry. I just wanted to get out of there and have some food and some coffee. My very last interview was with this man. So I walk into his office, and there's an older naval officer with me who took notes. They sit me down in his infamous wooden chair, which is tilted forward so you can't really sit on it. And he starts peppering me with questions. and I answer them as best I can. Some interesting questions. Why did I choose engineering? What do I know about the U.S. Navy? What's the size of the Navy versus the Coast Guard? Very interesting how he was probing what I knew. But the final question he asked me, he sat back in his chair and he looked at me and he said, "Letelier, why do you want to work for me?" And I said, "Well, Admiral, I'm an engineer and you're giving me a chance to do engineering." He jumps out of his chair and says, "That's bull, blank, 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 blank," and starts telling me what a garbage answer that was. And then he goes on for several seconds, seemed like an eternity, telling me how bad an answer with this was. Finally, he said, "Get out of here." And so I kind of slunked out of his office, figuring, oh, well, I'll go down the street to the Naval Air Systems Command and maybe I can design airplanes. So as I'm walking out, this wonderful young officer that works for him, who I later got to know fairly well, she motions me like this into her office, because her office was down the hallway from his. She tells me to take a seat. She gets out a manila folder and she says, "The Admiral has selected you for his headquarters organization. You're to report on board no later than June 1st. And the basic ground rules are you will not wear a uniform for the next 5 years. You will not salute. You will not use military rank. You will be transferred to the Department of Energy, and you definitely won't tell people what we do around here." A very interesting 5 years of my life. But I have to tell you, no man has influenced me more than Admiral Rickover in terms of making me the kind of engineer I became, and in many cases the kind of person I became. He was not a nice man. He had had a lot of adversity in his life, and there was nothing warm and fuzzy about him, but he was incredibly wise. He gave us some important points, sometimes at the top of his lungs. One of them was that as an engineer, I needed to know about everything. Yes, I might be focused on a particular area, but if I'm to be effective as an engineer, I need to know about everything. Mechanical, electrical, materials, chemical, nuclear, etc. Another piece of advice was this idea that you can build up to something, that you can work on a new design in pieces and use what you learned from the earlier piece to be the foundation for the next piece. Another one that really has gotten me through multiple periods of adversity is that Admiral Rickover gave us two pieces of advice that really are important. He said, even in the very worst circumstances, you always have 30 seconds to figure out what should be your next move. He said more people have died from taking the wrong action in a crisis than waiting that 30 seconds, thinking about it, and taking the right action. I found that to be incredibly useful in my life. And the last one is he felt sometimes the best way to solve a problem is to outlast the problem. And I think that advice really is holding very true with this pandemic right now. And I cannot tell you how many times that advice about getting through today and getting through the next day and the next day to outlast the problem has gotten me through some very challenging times. So that is it. Admiral Rickover did retire as the longest serving and most senior officer in the entire U.S. military. I met him one last time after I had left his organization and gone into amphibious warfare. He was not happy that I chose amphibious warfare, but I needed to do that to prove to myself that I truly was a naval officer, that I could get on my khakis, get haze gray underway, and that U.S. Navy sailors would in fact follow me into harm's way. Well, that is it for our series. We're going to continue then with the rest of the lecture, and please email me with your thoughts about this. So we'll see you in just a few minutes.